This is our third lecture, and we are going to talk about the powers and radicals. We are going to define the square root and the nth root of a positive real number, and we are going to express a positive number in scientific notation. We are going to rationalize the denominator of a fractional expression and solve equations with powers. First of all, let us talk about the powers, or make a quick revision about powers. You know that the power is the repetition of multiplication, and we have a power. When we say a power of 2, that means the exponent is 2. When we say a power of 3, the exponent is 3. So what if I have power n? That means I'm multiplying the number by itself n times. You know that a to the power 1 is a, and everything to the power 0 is 1. A to the power negative n is expressed as 1 over a to the power n. As you know, we have to put a condition that says that a could not be 0. Minus 1 to the power n is equal to 1 if n is even, and it's equal to minus 1 if n is odd. Powers having rational and irrational exponents. For example, if I have n radical a is expressed as a to the power 1 over n. When a is non-negative, n can be any index. When a is negative, n must be odd number. Example, if I have radical 7 is expressed as 7 to the power 1 over 2. b to the power 1 over 3, if I wanted to write it as a radical, it's 3 radical b. 15 to the power half is expressed as radical 15. And x to the power 4 y of third root is expressed as 1 over 3. Don't forget that you have to put the power inside. You know, I can write this to the power 1, so the power inside over the nth root. For any non-negative number, n radical a to the power m is expressed as a power m over n. So as I told you, the power inside over the root outside. For example, if you have b to the power 2 over 3, that means the 2 were inside and the 3 were outside. This is another example, so I can express it as 7 over 3. Now let us talk about some properties. For example, those properties you already know. Those are the properties of powers. If I have a to the power m times a to the power n, we add the power. If I have a n, all of it is power m, so I should multiply the power. am divided by an, we subtract the power, and if I have different base but the exponent is the same, I can multiply them and then put the power, only if I have multiplication. Sign of the power of a negative and positive number. If a is positive, then a to the power n is positive. If a is negative, and if n is even, then the number will be positive. If n is odd, a to the power n is going to be a negative number. Scientific notation. Scientific notation of a decimal number is in form of a times 10 to the power n, where a is between 1 and 10. So it could be 1, 2, 3, 4, 5, and till 9. Example, 0.0314 is written as 3.14 times 10 to the power minus 2. So don't forget that this is the general form to write a number in scientific notation. Another example, 134.72, you have to move the point 2 times to the left in order to get it as a scientific notation. Square root of a real number. If I have x squared equals to a, don't forget that you have to take the first time positive and the second time negative. So there are two solutions for this equation. If a equals to 0, then I have only one solution. And if a is negative, we have no solution because we cannot have something square equals negative, because we already explained this. If n is even, I can't have an even number, a negative number. Now we are going to take some examples. X squared minus 25 equals to 0. How do we solve this? I just make factorize. So in this case, it's x minus 5 into x plus 5. You know this identity, right? So you have to factorize in order to get the solutions. And if you put them equal to 0, you have to take each factor equals to 0. So I will get x equals to 5 and x equals to minus 5 and so on. But in this case, x squared plus 9 equals to 0. That means x squared equals to minus 9, and this is an impossible case. Why? Because a square of a number cannot be negative. So this is impossible. In this case, I'm going to get x squared equals to 0. Then the only solution I have is x equals to 0. The last one is similar to the first one. You have to factorize, and then I will get two solutions. Let us talk about some properties. If I have radical a times radical b, I multiply the numbers under the same radical. If I have radical a to the power n, I can put the power inside. And if I have radical a over radical b, I can put them under the same radical, so a over b under the radical. If I have radical a squared, it goes out a if a is positive, and I should put it minus a if a is negative. Don't forget that I cannot add two numbers under the radical. I can only multiply them. Rationalize. How do I rationalize to when I have radical? You know this from last year. I just multiply by the denominator. So if I have radical 3, the only way to get rid of the radical is to multiply again by radical 3. So I will get 2 radical 3 over 3. It's okay if I have radical in the numerator, but I shouldn't have radical in the denominator. Another example, 1 over radical 3 plus 5. The only way to get rid of this radical is to multiply by the conjugate of radical 3 plus 5, which is radical 3 minus 5. So as you see, I multiplied by the conjugate. So above, I will have radical 3 minus 5, and under, it's now radical 3 plus 5 times radical 3 minus 5, following the identity a plus b, a minus b, I will get a squared minus b squared, which is minus 22. So now the final answer, I have in the denominator only numbers, and in the numerator, it's okay if I have radical. What if I have nth root? How do I rationalize this? I multiply by, as you see, I multiply by 5 radical, but I have to put the power minus 1. So if it's 5, I should put it 4. If it's 6, I should put it 5. And so on. Why? Because Following the property, you know that I can put the two numbers under the same radical. So 2 and 2 to the power 4, they will give me 2 to the power 5. So this is the only way to get the same exponent as the root to get rid of them, and the answer will be 2. Okay? So don't forget this. We call nth root of a any real number x such that xn, x to the power n, equals a. So if n is odd and a is any real number, then x to the power n equals to a is equivalent to nth root of a. So if I have, for example, x to the power 3 equals minus 8, the only way to get rid of the power 3 is to put the root 3 of the number. This is the only way, because if you put here 3, you will get rid of the power. So I only have x. Don't forget that you have to put on both sides the same root. Okay? And it's okay if I have minus inside the radical if the root is odd. Okay? So as you see, x to the power 5, the only way to get rid of this power is to put 5 root radical x to the power 5, because I will get rid of them and I will get x. Properties. If I have the same root, I can multiply the numbers inside. If I have also the same root, I can put them under the same radical. Example, for the first one, as you see, fourth root of 48 and fourth root of 3, I can put them under the same radical. So I will get 16, and you know that 16 is 2 to the power 4, so the final answer is going to be 2. The second one, as an example, I will take 3 third root of minus 27 is going to be minus 3 to the power 3. So the 3 will cancel the root and the final answer is minus 3. Those are some examples that you can apply for all the things that we have covered regarding the root, how to solve, and how to rationalize.